The question is an AC source of 50 volts RMS, frequency 100 over pi hertz, connected in series with an inductor of inductance capital letter L and a resistor of resistance capital letter R. We are also told that the effective current in the circuit is 2 amperes and the potential difference across L and R are 30 volts and 40 volts respectively. A, we are to calculate the power factor. B, the inductance of the inductor. And C, the impedance of the circuit. Let's go to the class. All right. From the question we read, we have this circuit. And the first one, we want to find the power factor. So the information supplied, our current was given as 2 amperes. The voltage due to resistor is given as 40 volts. The voltage due to inductor, all right, was given as 30 volts. The effective voltage from the source, that is Vrms, was given to us as 50 volts, and then the frequency of the alternating current was given as 100 over 4 pi hertz. So we have this. By definition, power factor is resistance over capacitive reactance. This is by definition. It could also be defined as the cos of the phase angle. In this case, this is, since the phase angle was not given to us, we have to use the first one. Right? Power factor equals ratio of resistance and the inductive reactance. So we're not given inductive reactance from the question, so we have to look for it. The same thing with resistance, but we're given their respective voltages and current, so that could help out. So from Ohm's law, our VR is equal to current times resistance, right? Or you can say Ohm's law, voltage is equal to the product of current and resistance. So to be able to find our resistance, this simply means that resistance is equal to V over I. And then V our R equals V over I. And then if we substitute, we are going to have 40 divided by 2. Therefore, our R is equal to 20 ohms. We also go ahead to find the inductive reactance. So our XL, similarly, XL is equal to V due to inductor over current, because the current that is passing, they are all in series in the circuit, so the current is the same at every point. So this is going to give us 30 divided by 2, and our XL therefore is equal to 15 ohms. Hence, our power factor, which is equal to R over XL, will be equal to 20 divided by 15, and that's going to give us 1.3 3, all right, 3, it continues like that. Um, that is our f prime is equal to, or approximately equal to 1.33. That's the value of the power factor. The second part of the question, we want to find the inductance L of the circuit. So inductive reactance is defined as the angular velocity times the inductance. All right? And angular velocity is always defined as 2 pi f. F was given to us from the question. So if we bring this value here in the place of angular velocity, this is xl, then if we substitute our values, our 15 is equal to 2 pi from here. The value of frequency, all right, the value of frequency, we put the frequency there. So if we have 15, it's going to be 2 pi and then multiply by 100 over pi times L. Pi will cancel out. All right. Our L, therefore, is equal to 15 over 200. It's going to give us, if you divide, that's going to give us 0.075 henries. Henries is the unit for inductance. We're asked to find the impedance. Our Z squared, all right, recall that our Z squared is equal to square of resistance and then the square of inductive reactance. So the impedance is equal to square root of R squared XL squared. So if we put the values, we have 20 squared plus 15 squared, all under square root. That gives us 400 plus 215. If we add these two, we have 625. If you find the square root of this, it's going to give you 25 ohms. So that's the value of ZRL is equal to 25 ohms. And